This is a cutout from one of your problems where we're talking about Marco's tile pattern, and they're using the relationships that you see to help you understand what's happening with parallel lines in a transversal. So just to work through some of the vocabulary here, you have these lines right here that I'm going to highlight in green, which are parallel. And you know they're parallel based on this little double arrowhead mark that they put right here. Okay. And then you have a transversal. So the transversal is a line I'm going to attempt to draw and highlight through right here. It's this line. And I'm going to highlight it yellow just so you can see it. It's this one right here, JK. So you can see that line. It is called a transversal because it dissects two or more lines. Okay, so let's get rid of that so that you can see our picture now. So here's our transversal, JK. Here's our two parallel lines, LM and NP are parallel to each other. One more time, those are the little notations so that you know. And this is a section of a bunch of parallelograms that are all put together in this fancy tile pattern that this guy Marco saw on the street. So you have to remember some things, like this is just the corner of a parallelogram, just like this is the corner of a parallelogram. They also form vertical angles, so they have to be equal to each other, which means A and D are also vertical angles, and they have to be equal to each other. X and Y are vertical angles and equal to each other, and W and Z are vertical angles and equal to each other. We also know by playing with those parallelograms and doing some rigid transformations that whatever value ends up in this angle D, it's going to end up being the same one here, because I can take a copy of this little section and translate it straight down here, and it's going to end up being the exact same shape. And we did some of that on the little tile pattern video. So if that doesn't make sense to you, go back and watch that tile pattern video one more time, please. But there's some other things that we can also remember and remind ourselves about when we're talking about these angle relationships here. This relationship between B and D, I have a straight line formed by the transversal. So the angle B and D have to add up to that 180 degrees because together they form this straight line. Same thing is true between A and B. So you have this straight line, LM, and if I cut it with that transversal, that's okay, but you have to remember that A and B have to equal 180 degrees. So that being said, there's all kinds of information you can decipher from this. Like if I give you a value for X of 60 degrees, you should be able to tell me that Y is also 60 degrees, and that B is 60 degrees, and C is 60 degrees. And because you know that, you should now be able to find A, D, W, and Z. So let's go back to my 60 degrees right here of X. Since X and Z form supplementary angles or a straight line angle pair, Z has to be the difference between that 180 degrees and my 60 right here. So I take 180, I subtract 60, and I get 120 degrees for angle Z, which means angle W has to be 120 degrees because they are vertical angles. And angle W and angle A are the same. They're corresponding angles in two different parallelograms. So this one also has to be 120 degrees, and this one has to be 120 degrees. So once you understand that relationship, plug some numbers in there so you can see it with some numbers. It's going to open up a whole lot of other options for you when you start trying to find missing pieces inside of parallel lines with a transversal.